So with that, without further ado, buon apremidi, buon pomeriggio. Voglio offrire un caloroso benvenuto ai nostri ospiti illustri dall'Italia. Bon après-midi. Aussi, j'aimerais souhaiter une chaleureuse bienvenue à nos collègues de Québec, Canada. Good afternoon. This is my name is Roberto Mazzolin. I serve as the Chief Defense Security and Technology Strategist for the Rhea Group. And I'm accompanied with Mr. Dave Anilkumar, who is a session coordinator. And I'd like to welcome you to Working Group 1, entitled From Earth to Space, and where we'll explore the technologies and skills that are currently being developed on Earth and are now applicable in space. Space exploration is leading to the development of life support systems on the Moon and beyond, effectively positioning it as a launch pad for further trips to Mars. Such areas of development include areas of food, energy sustainability, and a circular economy, and many of the very same challenges that we currently face on our Earth today. These include spin-in technologies and competencies developed for Earth that may be used for the advancement of space exploration. Indeed, the context of lunar travel has changed such that we're no longer looking at the Moon as temporary visitors, but more so that we'll stay permanently and use it as a base for travel and for exploration beyond. Consequently, this serves as an opportunity for us to consider the challenges that currently face us on Earth and apply progressive, cutting-edge technologies to focus and accelerate the development of important life-sustaining solutions that in turn can be applied back here on Earth for the betterment of mankind. To help us put this vision in context this afternoon, we're fortunate to have our keynote speaker provide us with his thoughts and perspective on this fascinating front. To that end, it's my privilege to please introduce Dr. Leonardo Mazzini. Dr. Mazzini, per favore. Dr. Mazzini serves as the Chief Technology Officer and head of the Thales Alenia Space Research and Technology Development and Product Policy Development Department, a key role in the shaping of corporate direction. He's a graduate of the Università di Sapienza in Italia in aerospace, aeronautical, and astronautical engineering. He's had a distinguished 24-year career with TAS, working through key leadership positions in the areas of avionic and satellite systems development, leading to his current role of platform, avionic, and propulsion product manager, defining policy for the various TAS competency centers. He has responsibility for TAS satellite platform products and has served as a satellite system engineering and technical director of many important strategic satellite programs, developing many observation and telecommunication satellites, such as the Cosmos SkyMed Earth Observation Constellation, SICRL 1, SICRL 1B, and 2, which are key Italian military and national security constellations, as well as closer to home, RadarSat 2, Global Star, Athena Fides, and ESA Sentinels. He's widely published and has produced a wide range of studies and research papers in avionics, attitude control, orbit control, navigation, satellite systems, and applied mathematics. And he's also authored a book entitled Flexible Spacecraft Dynamics, Control, and Guidance for Springer in 2016. With that, Dr. Mazzini, I turn the floor over to you.
Thank you very much for your kind words. So the subject that I am expected to discuss, to speak today, is very, very large, very wide. I will not treat it in the way in which it would deserve. The porting of technologies from, let's say, from the Earth business to space is immense. And it is a work that I continue to do every day in my life. So I will focus mainly on very few subjects that have to do with the Moon, have to do with maybe more recent works we did in my company. But I will be happy to answer to questions from you, from the colleagues here, the other speakers, on this very wide subject. So sorry, I will limit myself to this perimeter. So TAS has a strong heritage. You can put the presentation, please. Okay, thank you. Thales has a strong heritage in the field of human space exploration, mainly involved in the role of prime. Over time, we have developed a list of stakeholders in both academic and manufacturing fields with which we have actively collaborated to always be at the state of the art of technology, using spin-ins and spin-offs and looking into the world of techno-transfer also on other terrestrial markets. I want to say that it is impossible today for a company like Thales, but also for our other competitors, to stay at the front field at the state of the art of technology without collaborating with academy, research centers, and especially also with industries that work in, let's say, more classic, let's say, earth business. No, I would say now the technology are completely, there is no specific, let's say, space technology. Technology goes everywhere, digital technologies especially, and so we have to follow this track. Please, can you put the first slide? So our engineering is now oriented towards digital design and exploits the data that is collected over the years. We have this experience, like the Moonlander simulator. I've shown it this morning. I will show it again later. Concerning the AI applied to rover, the main research activities have been synthetic image generation and training, only by means of synthetic images, and validation by real images, autonomous navigation, training of deep neural networks for the rovers. You can put the video, please. It's the next one. It shows our rover in the training site. And this is a simulator that we built in order to instruct the rover to go, to explore the moon, to excavate, to find the samples. The rover detects, let's say, obstacles and moves through them. And this has been done with a neural network. This is an example that I want to show you. This is using normal technology now, today available normal technology. It's nothing strange, nothing particular. Okay. I think we can move to the next slide. This study, the study we did for the rovers, was called the CNAV project. We performed it co-funding by the Italian Space Agency. Another activity where we have been, non parte questo. Simon should move. Vabbè.
It was moving.
Ah, si è mosso già? È finito?
Sì.
Ok. Okay. Sorry. So, habitable modules and AI. Thales has designed the European Columbus Lab of the ISS and is managing the increments of it using the digital documentation produced directly in a virtual reality environment with the possibility of immersive remote interaction with astronauts. The Simon AI is the assistant of the astronauts. Now, I don't know if you have seen it, but it's a sort of ball moving in the space station. The movie Interstellar, in the movie Interstellar, there were assistants to the astronauts called TARS and CASE. Now, this movie is very resemblant of what happens today. It is not far from the reality of the space station, where a drone like this supports the astronauts' activities. We have recently passed, a few years ago, since we have a lot of computing power available thanks to supercomputers and cloud computing, to strong artificial intelligence, that is, machines able to develop self-awareness, learning, and improving their own behavior, helping us in the decision-making process without yet taking our place. So there is nothing, I would say, miraculous in AI. AI algorithms were available already some decades ago. This I want to tell you. This is, nobody invented nothing. What we have now is the availability of computers which are 1,000 times more powerful, or maybe more, than the computers available in the 80s and in the 90s. This is the only reason for which today we find these miraculous behaviors of our assistants and say of, come si chiama, OpenAI and so on. The next slide. Next slide show edge computing. Oh, I want to say also that both AI and high-power computing, edge computing, distributed computing capability are an important technology, not only for the moon. The moon, they surely are a necessity, but for the modern satellite technology, edge is a must. In any case, we are spending a lot of money on this kind of technology. But the moon has all the elements to implant AI and high-power computing and clouds, as I said this morning, connected to the Earth network. We are designing communication system between the moon and the Earth, high throughput. We are designing systems to, let's say, refresh computers and HPC on the moon. And we have also power sources on the moon. So we can install a high computing capability. Finally, I want to speak in my last slide, please. Okay. Of another technology that is not very much mentioned. Maybe this morning, the representative of ASI spoke shortly of it. The importance of autonomous manufacturing. If we want to go to the moon, but not only on the moon, we have also projects to integrate assets and systems in space. We need to have autonomous manufacturing, so the capability to build spaceships, for example, or regolith houses directly on the moon or in the space directly. Now, this is a very difficult subject. The space industry is not used to autonomous manufacturing. What we have started to do is to design a factory, a space factory, which is almost fully autonomous. We are building it, and we have put inside this factory in Roma a lot of AI technology. Robot and cobot assisted production, AI-based process control and planning. We do quality control of the process through cameras, and an AI system control that everything is performed correctly. Data-driven manufacturing with virtual reality and things like this. You can see in the picture some imaginative, clearly the factory is not finished. We are in the process to building it, but this could be a possible cooperation also between Italy and Canada, because when this factory will be finished in a couple of years, we will be capable to produce 5 satellites per day from this factory. The last slide, I want to stress what I said at the beginning. It's impossible for a company like us to stay at the front of technology without cooperation. So we need cooperation both with our industries, with small industries, large industries, but also with research centers. We cannot spend our money for all the technology that we need. So for this, we have created in Italy a larger network, and we are also willing to increase it with many important universities, Polytechnique di Torino, Polytechnique di Milano, Alma Mater in Bologna, but you know, we are almost everywhere, apart Calabria, but in reality we are also in Calabria. I don't know if there is somebody from Calabria here, because I was speaking before with a professor, Professor Basso from. So our wish is to implement the cooperations also with the Canadian Academy, certainly, on the subjects that I have shown to you. And I hope that we can work together. It's also a matter of understanding how to finance the projects. So we can put our money, but we need also co-funding from the agencies, from the Italian and the Canadian agencies to define a win-win approach to a number of challenges. Another possible cooperation is with the industry, obviously, with the Canadian industry. The Canadian industry has an excellent. I have been technical director of Radarsat 2, and I know MDA very well, and I am really proud to have been working with them. They are very clever in many technologies, digital technologies, software. We learned a lot working with MDA. I don't worry to say that. I am personally, certainly, we have done also with them many technologies. We have developed a satellite, but really they are very, very clever. So this completes my speech, and maybe later in the discussion we can give some answers to this request of collaboration.
Absolutely.
Okay.
Thank you very much.
Thank you.
Well, Dr. Mazzini, I'd like to thank you very much on behalf of the conference for your tremendous words. I mean, you've been able to certainly very concisely, very clearly outline many aspects of Earth to space technologies, how technologies that we see common day to day being applied in outer space, and the space factory concept, I think, is marvelous. And your genuine intent in reflecting a desire for collaborative work between Italy and Canada will certainly make that a feature as part of the discussion we have and the follow-on from the conference. So thank you very much, sir. So now to the conduct of the workshop. You know, so we're very blessed to have here today a tremendous demographic of technical and specialists. And what I'd like to do is be able to provide everyone an opportunity to speak, but nonetheless have this as much of an interactive panel as possible. So we've identified 2 questions that'll help frame some of the key issues of space exploration from the perspective of capabilities that are relevant to our terrestrial environment and how they may be applied to outer space or impact it, if you will. So the first question is more squarely focused on the relevant technologies, and the second one has a slightly more geopolitical or policy flavor to it, and that's maybe where we can discuss some of the collaborative opportunities. So this way we can hope to capture a broad range of relevant perspectives. So what we'll do is we'll go round robin for the first question, and then we'll proceed with the second question. So pending the progress, we'll follow up with additional questions or simply a 1-minute individual synopsis towards the end of the session. We're shooting for around 15 hours. So if possible, if we can get some additional questions in, or at least a synopsis. And then we'll keep about 10 to 15 minutes at the end for a brief synopsis of paddle outcomes and a Q&A session where the audience can pose questions to the audience, to the panelists. So to the panelists, consistent with the theme of the conference, which we look to take to the output of the sessions and collate it into a final product and be shared with the respective ambassadors, agency, and industry leaders, what we were hoping to be able to do is get your perspectives in terms of what are the challenges, what are the issues, what needs to be done, and then identifying potential opportunities for collaboration, bilateral collaboration between Italy and Canada. So, and if possible, in respect to your panelists, if we could keep the responses to about 5 minutes, and then we'll go from there. So I'll frame the premise. You know, it's quite clear how technologies have developed for space missions, and they've had a significant impact on Earth. The new paradigm of the space economy, or the most modern one, the new space economy, mimics the digital versus analog industry disruptiveness change that happened decades ago. And it's got a pivotal role in Earth-based technologies for the benefit of space. Space exploration has captivated the human imagination for centuries and has helped to drive us to venture beyond our planet to uncover the mysteries of the cosmos. Today, we're in the modern era with a fascinating world of space exploration. From the first space mission to the present reality of humans walking on the lunar surface and satellites orbiting distant planets, the advancement of technology is undeniable. Mars, in particular, has become the focus of exploration with robotic missions like Curiosity and the Perseverance rovers, Ingenuity, a helicopter actively operating on the surface. Closer to Earth, the intent is to establish permanent facilities on the moon. Many of the existing exploration platforms are equipped with ML to autonomously undertake missions and analyze samples. And further, we have recent discoveries, such as the first ever detection of gravitational waves, images of the black hole, the deepest, sharpest images of the universe to date from the James Webb Telescope. For these achievements, AI and machine learning have assisted to some extent, but advanced use of artificial intelligence space missions is yet to be realized. AI could play a pivotal role in the exploration of space. So for example, AI is being used in the areas of autonomous navigation, resource management, data analysis, enhancements in satellite imagery, exoplanet discovery, risk assessment, fault detection, mitigation, and decision-making. The question presented in this portion of the panel discussion aims to dive into the various aspects related to space exploration in this context. So the first question is, how much, in your opinion, is space exploration relying on non-space technologies and competencies to further advance and accelerate the design of a new mission? Are you taking advantage of an open innovation approach in your business? So what I'll do is to tackle this, I'm going to start and I'll go by alphabetical order. So first, Signor Giovanni Beltrame, who is Professor of Computer and Software Engineering at the L'École Polytechnique and directs a MIST lab collaboration with ESA, CSA, and NASA. Sir, can I invite you to provide some of your thoughts?
Thank you. So first of all, I'd like to say a couple of words of where I come from. So I'm a professor in computer and software engineering now, but before I was working at the European Space Agency in the microelectronics section. And I think that starting 15 years ago, we've seen the deep need that the agencies had of transferring the fast advancing compute technology from Earth to space. Basically, whatever you want to do in space, the main driver, in my opinion, of this is compute. And the problem is that whenever you take computer chips in space, you have a lot of issues due to radiation, temperature, etc. And the fact that now we are able to use what we call components off the shelf and use them in space is what is actually enabling the importation of all these technologies that have been developed on Earth in terms of machine learning, control, image recognition, image generation. So all these things can be transferred to space. When I started at the European Space Agency, I was a classic example of the agency trying to bring technologies from Earth to space. In fact, I was not working in space at all. I was working at ST Microelectronics, and I was doing digital still cameras. So something completely different, but I was working on multiprocessor systems. And that's what the agency thought was the future for space. Bringing this technology to space to improve the compute and then enable all these new technologies. If you look at nowadays, we have one of the main factors that changed everything was the shrinking of the transistor size. Because as you shrink the transistor size, you reduce certain radiation effects that you can have in space. And these chips can last for much, much longer than they were expected to. So this movement is what basically made everything possible. And now we have neural accelerators working already in space. We have the ESA that has sent an experimental CubeSat with a neural accelerator. It's Movidius chip. And we have also reprogrammable hardware that can be used and to do all these kind of activities. So the technology developed on Earth is going to space, in my opinion, thanks to the transfer of compute capabilities. And this is the end of my first statement. Thank you.
Thank you very much. Appreciate it. Very focused discussion. I don't think we have Andrea Cavallini yet. What we'll do is we'll keep him at the end of this next of this group. Okay, so the next individual, Mr. Remi Duquette, who serves as the Vice President Industrial AI at Maya HTT, and has been involved in dozens of successful AI, machine learning, and simulation projects. Remi, can be interested in offering your thoughts on this. Thank you.
Certainly, Roberto. Thank you. Thank you very much. Glad to be here in this great company around the very seasoned panelists here. So Remi Duquette, I'm in charge of a group that has deployed about 150 different AI projects in manufacturing in different industries, aerospace and others combined. So it's kind of funny, I started in space. I worked on 7 spacecraft over my younger years. And so it's 0.07% of the world's satellites that are orbiting, roughly speaking, data scientists speaking here. And over the last 10 years, I've essentially grew this industrial AI expertise mostly in manufacturing. And it's kind of funny now, full circle back, going from Earth to space. Going back into space applications because, of course, there's low volume of data in the manufacturing shop floor, and most, of your shop floors on the spacecraft manufacturing side of things. And applying AI to this low volume business is very interesting and intricate, and can benefit from it at the volume of satellites and this, the constellations that are coming out, MDA and others. It's going to be a challenge for them to move from more unique kind of one-offs to multiple satellites. So that kind of transition is where we've applied a lot of AI technologies for improving the quality and the productivity and improving the shop floor workers in the process. So that's going to be an interesting motion. Now back to the compute side. On the AI front, when you go to space, one of the things that we've certainly seen on the planet here, and that will be a challenge moving forward, is it's statistical based, right? So you do have false positives, false negatives that will show up, whether you like them or not, right? AI-based technologies will always have those kinds of caveats built in based on the technology. So looking at applying those with safeguards. We've talked a lot about biases and other things down on the planet here for large language models or other things. Well, it's the same thing when you look at telemetry or images or other types of input signals. You'll have to safeguard those AI models. So in terms of a community here that we need to work on certainly is improving and reducing those unintended consequences on the AI front that we will put into space in various ways, shape, or form, whether it's for analyzing Earth samples or moon samples or other things. Been on a program where we've done some work with the rovers on Mars, and just the latency of the data that comes in, AI may or may not be trained on all these latency issues that will show up in the data in different ways and shape or form. So anyway, some food for thought, but it's an interesting world to move back AI into space in a bigger way.
Well, it's very fascinating because you've illuminated a number of points, especially with regards to false positives in the AI environment that actually impact mission-critical systems on Earth. But the context of latency is actually another added dimension that's very, very interesting. Well, thank you very much for that. Next, I would like to turn the floor over to Dr. Guinness Kurt, Associate Professor, Department of Electrical Engineering at l'École Polytechnique, and she's also Canada Research Chair, New Frontiers in Space Communications. So, Dr. Kurt, please.
Thank you. Well, thank you for this excellent organization and having the opportunity to explain our thoughts. My background is on wireless communication systems, so I'll try to address the problem from the telecommunications perspective. So what's happening these days, as we can see from the news, is we are trying to directly apply the earthbound technology on the moon. For example, if you see Nokia's LT base station plans, deployment plans on the moon, it's basically we have a technology and we want to deploy it directly on the moon. But the issue is what we have on Earth is designed for specific objectives. That's mainly, for example, targeting a maximization of data rate. We don't really worry about the power consumption and all that stuff. Now, when we want to use the same learning and same technology in space, we need to think about new objectives, perhaps include multifunctionality in these. So currently, some expensive technologies, for example, wireless energy transfer and all those things, may be more viable. So we need to actually look at the problem with a fresh new perspective, maybe with a blue sky design approach a little bit. Of course, we need to reuse what we learned, but it's not use it as it is kind of solution. So for instance, we already read about the problems that the SpaceX satellites are causing for the radio astronomy. So we need to learn about the constraints and the possible implications of the current solutions, and we need to somehow refresh our designs before taking them to space. So that's what I can say at the moment. Thank you.
Some tremendous observations. I hearken back to my graduate studies in satellite communications, and we were learning all about different coding theories and error correction schemes, and when one extrapolates that to the modern contemporary requirements of developing a web in outer space, the World Wide Web in outer space, against some truly challenging issues, and it's good that you're guiding the National Research Chair in this. It sounds like a fascinating opportunity.
Thank you.
Next, I would like to turn the floor to Riccardo Lasagni Manghi, who's a postdoctorate researcher at the Università di Bologna and at the ESA in the radio science and planetary exploration side. Please.
Thank you very much for the introduction. Good afternoon, everybody. So, as mentioned, I work at the Radio Science and Planetary Exploration Laboratory of the University of Bologna, and my research area mostly focuses on orbit determination and gravity science towards small body missions, so towards asteroids and comets. In particular, I'm involved in the Hera mission, which is currently scheduled to launch in October 2024 to reach the binary asteroid system Didymos. So an issue which is starting to arise in deep space is basically that the number of missions has been steadily increasing over time. And also we're switching more and more towards a multi-spacecraft design approach, where basically you have a mothercraft which carries one or more smaller CubeSat on board and releases them directly at the target. So of course this gives you a lot more flexibility in terms of scientific return, because the smaller CubeSat can take significantly higher risk. They can go into lower orbits and have different observing geometries. But at the same time, the problem is that we need more and more, let's say, manpower to control the spacecraft, because traditionally each mission, each spacecraft would need its own flight dynamic system, its own mission control center, and especially for the mission critical phases, so maneuvers, landings. But of course, we cannot just increase the number of persons involved. So in this field, technologies such as computer vision and artificial intelligence can be enabler technologies, because they allow to have to reduce the human interaction and more to rely on these technologies for autonomous decision making. Going back a little bit to the second part of your question, so the open innovation approach. Also in our sector, this is something that is still a little bit in the works, but I think that we're making a lot of progress, because in radio science and orbit determination, typically the software which has been developed is meant to be proprietary technology. This is the case, for example, of the Monty software, which was developed by JPL, by NASA's JPL, which is of course a very powerful tool used in many mission cases. And it's specifically tailored for the JPL needs. But of course, if some of the external users, like for example our university, wants to use the software under license, there's a limit to what we can do with the software and to the accessibility we have. So a completely different approach, which is the current one followed by ESA instead, is with its newly developed Godot software, is basically to have an open source approach. So basically you have a few developers which are building the backbone of the structure, but then the code is accessible to all users around Europe or ESA member states. So you have full control on the software. You can create your own functions and upload it for the community, or you can even use it for commercial applications. So it's up to you, basically. There's no clear winner between these two approaches because everyone has its pros and cons, but in my opinion, we're going more and more towards that direction. So open innovation and open source software even apply to orbit determination.
Very interesting. Interesting to see the dichotomy between the two innovation approaches. It seems that the open innovation construct is becoming certainly probably positions itself as a better means for active collaboration, certainly within communities and as well as between nations working to similar ends. So thank you very much for that. I see that now we have Andrea Cavallini on screen here now. I believe Andrea is the Earth Observation and Artificial Intelligence Specialist Project Manager at Rhea, and he's been involved in driving much of the work being done in Esrin, part of the European Space Agency. So, Andrea, I hope you can hear me.
Yeah, can you hear me?
I think you may be on mute. Or disappearing. No.
Can you hear me? Can you hear me?
Okay, we're good.
Okay.
Grazie.
Good afternoon. Sorry to not be here with you. Unfortunately, I have to stay at home with the kids. But okay. As been introduced by Roberto, I'm responsible of artificial intelligence and machine learning activities in Rhea since a couple of years. And of course, we are challenging a lot the implementation and usage of artificial intelligence in many fields. We see that there are many opportunities. Of course, let's say the main issue behind the artificial intelligence is not, let's say, the way to solve the task that often with many research and paper and a lot of work done by universities, something that you can find in some easy way how to tackle some task. Often the main challenge that we are facing with artificial intelligence is the data. The data is, let's say, the most important part of any artificial intelligence applications, because from one side, you need to collect a lot of data often, but most of the time, even if you have a lot of data, it's not valuable data. So you have to deal with maybe the scarcity of good data that you could use, and or the fact that in some way you have to assess the fact that the data is not of quality. And every time you have to work with AI, you usually have to face the issue about bias. So how you guarantee that what you are doing is unbiased, that the result is as expected, and that you are going to deliver something that is good and works in most of the cases? That is, let's say, one of the most challenging that we are facing today. And also that if you want to make an application that is as much as possible generic and that can be applied on several different fields and contexts, that means that you are going to increase the data. That means that you are going to increase the time for training the neural network, or the complexity, or both. And then this means a lot of time that you have to deal on data preparation, data sanitization, training itself. And then it also implies a lot of money, because of course, in order to have a good and network that is trained in a good time manner, you have to exploit a lot of computational power that comes from GPU. And is one of the most, let's say, issue in terms of money that you're going to face when you are going to work with artificial intelligence. At the same time, another good challenge that is something that we are now trying to implement in our pipeline is a way that you can implement what is called explainable AI, because often AI is seen as a sort of black box, a magic black box, when you put data inside and then you see in the output some results. But often in some contexts where you have to deal with very delicate tasks, maybe in case of satellite maneuvers or in the field of military and defense, you cannot simply say, okay, you have to trust me that I've got validated the solution. You have to find a way, and this is what, when it comes in hands of the explainable AI, where you you show exactly how the internal structure works in some way that can be trusted by the client, and can be, of course, something that it's not like by magic. So I think that there are many issues that we face every day, but of course it is a challenge, and today something that it's impossible not to embrace in any company. Today also we are looking at often we reply usually to 3 questions. If it's something that we can do better or in a more accurate way with AI, something that today you are not able to do except with AI, or something that can be improved by AI. For instance, also we had some experiment also in the satellite maneuvers, when there are many complex calculations that takes a lot of computational resources. Something that can be speed up and made in a faster way with the support of artificial intelligence. So there are many fields where you can apply artificial intelligence. And of course, you have to focus on one of them, because there are many specificity on each field, if you are going on computer vision or natural language processing and so on and so forth. But as I said, today I see that the future will be mostly on using our artificial intelligence. So that's our main experience on this field.
Well, thank you very much for that, Andrea, and you've really captured the essence of some of the principal challenges of the use of artificial intelligence, that being the data. So you've actually made a very compelling case for the importance of maintaining the human in the loop, if you will, in support of key decisions that are based on AI implementation or support to critical systems. Thank you very much. Next, I'd like to
thank you.
Grazie mille. Next, I would like to invite Melissa Mancini, who is a mechanical designer at the MDA. She's had a 13-year experience. We've been involved in antenna mechanical design and manufacturing engineering, so very a breadth of experience in the space domain. So please be grateful for your insights.
Thank you. So as you said, my background is more in design. Mike? Yeah. So my background is more in design and manufacturing. And, in and out.
I'll maybe keep it closer.
Here we are. If that works.
Hello? Okay. So my background is more in design and manufacturing. And at MDA, we make products for satellite systems. And as has been mentioned numerous times today, satellite missions have gone from being a mission with a single satellite to a mission with a constellation of satellites. And so before, where we were used to just designing and building a few satellites a year, we now have to figure out how to design and build a much more significant amount. So in order to handle that increased production rate, we had to move away from time-consuming, manually managed processes and manual assembly, and move towards processes that use AI and automation. So we looked at our entire production flow, from procurement and planning all the way to assembly and testing, to see how we could adapt that to high-volume production. So a little bit what Leonardo was saying before. So on the procurement side, we implemented AI to look at historical supplier data to see how we could better predict deliveries. In planning, we're using AI to improve visibility on shortages and delays, and improve and optimize our production scheduling. In manufacturing, we're moving more towards an assembly line, similar to other industries that have high volume production. And we're implementing automation, augmented reality workstations, robots, and cobots to be able to help us in the assembly, testing, and inspection of our hardware at various stages in the production flow. So this demand for satellite constellations just keeps growing. We need to continue to rely on other technologies, other competences, in order to keep up the pace. Otherwise, we'll just be left behind. Regarding your question on open innovation, we do that quite a bit at MDA as well. We've had some programs where we provide satellite products to customers that are first-time satellite providers. And in working with them, there's an understanding that there will be some transfer of knowledge between us and them, and also we'll support them in learning on how to design and build satellites. Also, another example is additive manufactured parts. we work collaboratively with the company that makes those parts for us to determine the process and parameters needed to make those products viable for space. And in working with these companies that are first-time producers in the space industry, they bring a different background and knowledge and ideas to the table, and that helps us all advance in our space missions.
Yeah, well, fascinating, and I like your analogy to the application of these manufacturing techniques that are, one would have thought were in the traditional industries, how it's being applied to space. I'm just interested, just very quick interjection. When you spoke very quickly that when you're optimizing things using AI, and you're developing a bespoke capability that's being manufactured at large scale, what kind of time is required when you're taking on a new satellite provider? Are you dealing with different people, you know, in terms of ramp up, in terms of being able to purely like interface from a manufacturing and design perspective?
It does take some time, and we've so right now we've I think it's known we've won the Lightspeed contract, and so to get to that point, we've had other contracts where we've slowly been ramping up in our number of satellites that we produce. And so you kind of use those ones that are a little bit smaller scale to help you debug and work out processes, and so that can be used on larger scale programs. So it does take a while. It's been taking a few years.
Super, fascinating. Thank you very much. That's some great insights. Next, I'd like to introduce Signor Giovanni Martucci di Scarfizzi. He's the Business Development Manager at Rhea. He's had a background with Thales, Alenia Space, and ASI, in dealing with ground segments for the ExoMars rover and the International Space Station. So he brings some tremendous experience to us here today. Giovanni, per favore.
Thank you, Roberto.
I think we've got another.
Okay, yes, here we are. So thank you, Roberto. Thank you very much. And I'm really happy to be here. And joined Rhea mostly 1 year ago, November 1st, 2022. So I'm really happy to mostly celebrate my first anniversary here with you. And as you mentioned, I had a chance to work quite a bit in space exploration, if you will. So both on International Space Station as well as in robotic exploration with the ESA, ExoMars rover, and ISS. And stemming from this experience, I can definitely join all the other panelists and also what has been said this morning about the potential benefit of AI in disruptively and tremendously improving the capabilities of mission returns, especially when AI would be, let's say, run on board, something that it's not yet, we are not yet there, as was already mentioned before. But just consider the possibility to select what data shall be returned to Earth, for instance, from a long distance, such as from Mars, and to have the capability at source side to identify what is actually of value for the end user. So very important. But there's another point that I would like to mention that was briefly touch-based earlier at the luncheon, and it's also the potential negative impacts of malicious utilization of AI in space. And I was quite fascinated some months ago when I had the possibility to attend to a presentation made by European Space Agency officer, where he presented a lot of Earth observation images that were stunning, perfect, very interesting, but they were actually fake. They were generated through AI. And these, to all of us, should pose a real problem, because consider the situation where, for instance, you have a decision maker that has to take some decision, and to do so, it bases its decision on fake images. I mean, the consequences can be really, really, really bad. And so in this sense, coming to your question, I think that the general topic of the security intended as security of data, security of the source, and trustfulness of the source onto whom you rely, it's very important as a topic and an enabler actually for future mission, especially when considered under the angle of space economy. So to have a broader view, I would say that definitely cybersecurity, so the protection of space assets and the possibility to, let's say, confirm and somehow certify that the information, the data, the product that you are receiving on Earth are actually what you are expecting to receive, and that they are produced in the way they are expected to be produced, is something that I would say is definitely something to be taken into account and will become and shall become an enabler for future space economy mission.
Oh, grazie mille, and some very interesting perspectives there, Giovanni. I mean, you really highlight the issue of the credibility of the information that's coming back AI, and it has a particular context in, well, particular importance in the context of the international strategic space competition that's now starting to emerge from between East and West, and when you know, the weaknesses in artificial intelligence can actually be seen as creating challenges, if you will, in terms of the integrity of information, the integrity of critical missions and capabilities that are being launched, and that can be used in a malicious way to be able to compromise an adversary's operational system. So some very, very ponderous thoughts there. Thank you very much. Next, what I would like to do is turn to Mr. Rob Philpotts, who I've known, he's serves as the Director of Cyber Threat Management and Response at BDO Canada. He's got tremendous previous operational experience in defense and government as a Canadian Army signal officer. He served in the Intelligence Fusion Center in Afghanistan. He's also been involved with NORAD, NATO, and U.S. Cyber Command. And so certainly, I'm sure you'll be able to bring an operational flavor to this, Rob. Welcome.
Thank you. All right. Thanks, Robert. Appreciate it. Yeah, so I had the opportunity in my career to see in the last decade the sort of addition to what they call the domains of conflict. So space and cyber to be added on top of air, land, and sea, right? Sea being the most, and land being kind of the most ancient domains of conflict, right? Air for the last century, and now here we are with cyber and space in the last few decades. So when you see that, you see how risks, how awareness of threats, awareness of vulnerabilities, and how that drives risk reduction on a massive scale when you consider how nations prepare for war or for conflict across all of these domains. Now, the question is Earth-based technologies that sort of, take us to space. And when you see manufacturing here on Earth, I think of things like, we see a lot of organizations where they're carrying out very important actions for the community, for the world, but they don't pay attention to their cybersecurity. And then they get hit, and then something happens. So this is an industry that's going to propel the world economy for centuries into the future. And I really do, hope to see that folks are addressing some of the fundamentals here on Earth before we proceed to space. So what does that mean? It means, like, for example, thinking about your supply chain. All right, so the world order is changing. This is clear. The old world order is going to change in some way, somehow. We don't know how far, but it will change. So supply chains need to be absolutely trusted. We see these in the digital plane being broken, providing vast access to cyber threat actors, to entire corporations, when they go through the supply chain. So thinking of that in a space industry context is extremely important, because it is guaranteed that just like the first ships that put to sea, all right, this is something viewed by those who want to dominate this area as a primary target. So all of your organizations are definitely of key interest to rival nations. Space, a lot of wireless communication out there. This is a field day for intelligence operations out in the world, all right? So whether it's our allied collections, our rival collections, they are collecting information at a record pace. So you want to make sure that your data protection methods are fully sound, protecting it, your data at rest, making sure when you're transmitting your data, it is secure to the highest standard, making it quantum data proof. The US government recently published quantum encryption standards to make your data encryption quantum proof into the future. So it's very important to keep an eye on this. Cybersecurity measures. So knowledge of your vulnerabilities. So vulnerability management, really started back officially when the U.S. government was trying to secure its nuclear launch process. It had 17,000 components that they tried to protect and make sure it was secure. Back in the 50s, so that an adversary couldn't trick or block a launch of this this very strategic system. Now, when you look at the vulnerabilities of an iPhone, let's say, we're talking hundreds of thousands, perhaps even more, not just 17,000. And then you think of satellites and very complex systems. This is proliferating at a great pace, and we see very sophisticated actors taking advantage of these vulnerabilities. So knowledge of your vulnerabilities in terms of technology, process, and even your people is vital. Luckily today, and I'll throw out there AI, all right? So we're able to actually, use some of these models appropriately, you're able to carry out very sophisticated, what we call attack path modeling. So where your sensitive system is, can a chain of vulnerabilities exploited put that asset at risk. So with AI these days, and the cloud security measures that we have access to, you combine those two things, you actually have tremendous opportunity to overcome some of these traditional disadvantages that organizations have had. So it is doable, and I just think really getting a hold of our security base at CRR is absolutely vital at this moment, and there's a lot of ways to get help in those areas. Thank you.
No, thank you very much there, Rob, and you've really characterized well the broader cybersecurity elements of this. So as opposed to just focusing on the intrinsic weaknesses or challenges of AI, you painted a good broad picture with respect to the cybersecurity impacts of that. So thanks ever so much. Next, moving along, what I'd like to do is introduce Signor Remo Proietti, who is the head of the Disruptive Energy Lab for Trailblazing Advancements at the Italian Institute of Technology, and he's a professor at the 60 Institute of Biomedical Engineering at the Chinese Academy of Science. He's got a previous experience in Japan and the Osaka University in modeling and simulation of micro and nanostatic scale technologies. So you certainly will be able to paint a very interesting international view on this. Signor Proietti.
I'm here. Thank you, Roberto. Good afternoon, everybody. I would like to go straight to your first question, giving a direct answer. Yes, I strongly believe that non-space technologies can be applied in space and then can help a lot advancement of the space sector. Why I'm saying so? You see, as you said, I represent the Italian Institute of Technology here, and which is a fairly new institute that was founded to work not in space. I really don't know anything about space. I'm not a space guy, I'm a theoretical physicist. And so that institute was made to work on, let's call it, classical sectors or fields. Computer science, material science, material science, I change.
Yeah, I better stick with the hand mic, I think.
And
I think we're good now.
Okay, yes, came back. I was saying 4 fields, 4 pillars: computer science, material science, biophysics, and robotics. You see, I've not used the word space here. What you have to know is that IIT is a small institute, about 2,000 people. And so it is easy for me, for example, to meet in the canteen or the coffee bar the guy working neuroscience, all excited about the action of their neurons, or a guy working or showing me the app in augmented reality. And this makes us talk a lot and made IT very interdisciplinary, so that we became very good in winning project, external project. We are good in talking, and so some of us started thinking, well, maybe we can exploit this advantage we have and move these things up to the space. But what is space? again, I don't know anything. Nobody knew anything about space in IIT. So we started to talk about with friends in ASI, in the European Space Agency, to ask for suggestions. And they gave us directions to follow. So internally, we started talking. And I was hoping to find many or some PI in IIT to embrace the idea. Well, you have to know that in IIT there are 80 groups, and 72 of them embrace the idea of space. And it was like this, very quick. This was so quick that in the last 3 years we won over 30 million projects, euros, either from European or from national level. And we set up in the end of 2021 something that is called Space IIT, which is a space center for space technology, if you want, in IIT. So this progressed, this went on, and now we are working with the agency to bring standard technology, let's call it standard, into space. Again, we are not a space research center. We don't know it. I learned in June that the solar system has 8 planets and not 9. From my daughter, who is 12 years old. She came home and she told me this. So, but we see that Earth technology in all fields, not only AI, can really be applied in space. And we have a number of projects now proving it. Okay, thanks.
Thank you very much, Remo. And yeah, certainly really brought to light the practical advantages of, of collaboration on this front, and also how far, AI capabilities extend in the non-space environment. So grateful for that. So last without least, I'd like to invite Signora Elena Tozong, who's the CEO of T4I. She's got a strong academic background in the field of space propulsion. And to bring another dimension to this whole discussion, Ms. Tozong, please.
Thank you so much. So my surname is not helping me as I'm the last one, and a lot of things has already been said. But in any case...
it's like wine, it gets better with time. Okay, so... Thank you.
We are moving, as Dr. Mancini said, from handcrafting to serious production. So we are doing propulsion systems for satellites, and we need to think about serious production, the same as the GT car industries, for example, in which you produce from 50 to 100 volumes and products per year, and that requires high-quality products. And so what is the challenge is to bring this concept, and pass through handcrafting to serious production, also when designing things for space exploration, also when manufacturing satellites for that purpose. And for example, we bring this concept while designing the propulsion system for the Milani satellite of Hera mission, in which we used we took something from the non-space based companies, as for example, we used some hardware parts that were not space grade, and we qualified them during this process. We thought about a design that was good for industrialization. And we also used agile instruments for the design process and for the management process. I would like to come also and to come to a concept that has been discussed this morning, where Marco Di Clemente said that we need space systems developed through artificial intelligence. And Andrea Cavallini before said that we can use artificial intelligence to speed up the processes. So I have an example here on what we are doing, as we are using neural networks for the designing of our electric propulsion systems and monopropellant propulsion systems. And while we were using genetic algorithms, think that the time of modeling for the post-processing of data was of 1.5 days, and now that 1.5 days has become of 10 seconds. And the next steps for us is to use this kind of neural network also for the diagnostics, And in this sense, we need to increase our training set. That is another point that is really important, to have a data set that can allow you to trust in the results that you can obtain.
Super, that was
Finished.
that was great. I mean, that was a whirlwind presentation, another added dimension to the manufacturing and the development capabilities, especially as it applies to propulsion systems. So thank you very much for that. So we're somewhat challenged with time right now, and we had posed 2 questions to the panelists, and they've been extremely disciplined in answering this first one, but I don't want to miss the opportunity to at least get their view on the second question. So very briefly, we've got about 15, 20 minutes left all told. The second question really was one, that related to the issue of space as an enabler for digital transformation, and which has become a centerpiece for socioeconomic sustainability and growth. So the question really explores how nations can prepare their space-related activities in combination with non-space activities for the digital transformation of their countries. So the question that we had posed to the panelists was, the space economy socioeconomic impact has been described as the same as the digital revolution on analog and traditional businesses. Are we shifting the digital economy needs, for example, cybersecurity, flexibility, computation, to space now? So if we could, and I'd like to get through everybody again, if I could ask you to please, if you can condense what you had prepared for a good 5-minute burst into 1 or 2 minutes, I'd be grateful for that. I mean, all your insights have been fantastic. So we'll kick it off once again. We'll start off with Signor Beltrame, please.
Yeah, as usual, I break the ice. So clearly, yeah, I think the answer is yes. So we have a new transformation. What makes the space economy, the fact that it's booming now, is fundamentally volume. Volume is what is happening. We have cheaper launch costs, we have more satellites, we have more companies, and that's what fostering the economy. So I think that we have a lot of needs that need to be transferred to space. The space is very different in the sense that we can't yet go out there and fix things that break like we do here on Earth. We cannot have the same maintenance schemes that we have for airplanes, for example, for satellites, because we can't reach them. So I would say that if nations would focus on the reliability and the certifiability of these systems to promote research in this area, that would be really a boon for the economy, because the certifiability, the trust we have on the system is probably the key effort that we have to invest in order to be able to have this this fast expansion of the economy in space.
Very much. So okay, absolutely. Talking about reliability there. Next, if we could, Andrea, please, if you could offer your quick 1 or 2 minute burst on this, please. Grazie. I think you're still muted.
Muted.
Can you hear me now?
Absolutely. Yep. Good to go.
Okay. Very, very quickly, I think that, of course, the space economy is one of a hot topic, and we work with that every day, and we use that. Our main application are based on space economy. But the main issue that depends on the physical event that we want in some way to monitor or to see. So often one we struggle is that the fact that maybe the resolution of the satellite is not enough. And so we hope to have more and more satellite with higher resolution, or in some cases maybe that we have the resolution but not a good receiving interval. So we are not able to monitor in a good, efficient way some phenomena. So for sure, there are many applications also thinking about hyperspectral data, satellites. As long as that we have the chance to have the access to tons of data, and we are able to detect many things. The important is that, of course, the amount of data and the continuity of data, that often, if we think with optical data that are often not so reliable, because you have the cloud, you have atmospheric correction that are not favorable for the analysis in long term. But today we have a very long historical data that we can let's say, many things that can be analyzed and can be improved with the implementation of artificial intelligence. So I think that there are still a lot chances to improve what we have, but already we have tons of chances to use in a very valuable way the space economy, and there are still many applications that we can be created. Also thinking about moving all the intelligence on satellite. So I think that there will be a very, very interesting future for the artificial intelligence applied to Earth observation. That's
Thank you. So thank you very much. You know, talking about the dependency on the integrity of the technical capabilities to support important social capabilities. So thanks very much, Andrea. Please, next, Senor Duquette, please.
Sure, thank you. So, I mean, when we talk about digital transformation, I think we need to remind ourselves that, you know, it's kind of this triangle of people, process, and technology. We tend to forget the people in the middle. So I think we're all in the digital transformation. It's inevitable. The tsunamis are coming and are here in terms of how we transform our organizations, whether it's family, business, or you know, country levels. But in the end, people are not changing as fast as technology right now. And I think we're being reminded of this. And when we look at applying AI into shop floors on manufacturing, first thing we run it up against are, well, there are people in the loop, human in the loop, and they will remain there for a little while, and if not for longer. And so my take on this is really to augment people in the meantime through AI, leverage AI to augment people first, before we think of, you know, taking the human out of the loop. And space technologies, once we start applying more pervasive AI in space, autonomy will become the issue. Autonomous AI is not easy. We talked about explainable AI and other components earlier that are being researched on, but it's not cooked, it's not baked right now. It still has, you know, hallucinations, as we've seen in. How many of you have used ChatGPT, GPT-4, and have seen hallucinations? Yeah, so, you know, think of that at scale. It will bring about other additional issues. So autonomous AI is, I think, a key element that we need to all work on to make this pervasive.
Again, another thank you very much. Another point, again, reinforcing the issue of human in the loop and the human limitations on being able to process data. So thank you very much for those comments. Next, please invite Dr. Kurt with your thoughts.
Okay, thank you. So I'd like to give an example from the satellite mega constellations in this case. So it is really a revolution with the networking aspect. All satellites are smarter and we have some computing in there. And it's faster to trade between New York and London using these satellites because free space optical communications enable us to send signals faster than the cables under the oceans. So it certainly enables us big opportunities, but the main issue that I see, in addition to those that are rightfully mentioned, like the security or the readiness of the technology, is basically the integration of these like a new space networks with the terrestrial networks or that we already have. So we need to buy special handsets or special terminals to be able to connect to satellites. So that is the main challenge that needs to be addressed. There are a couple of solutions, alternatives that are being thought, like having giant antennas in satellites, or making a cluster of satellites, or making use of high altitude platform stations, so on and so forth. But overall, I think there are still some research problems that we need to answer at the end of the day. So, but it will be at the end very revolutionary. Yeah.
So again, reinforcing the concept of how we expand this space web, if you will, and the technology and the impacts, again, on human processing ability, if you will. I mean, I see a theme coming out there. Next, Signor Manghi, Lasagni Manghi, again, grateful for your thoughts.
Thank you. Yeah, so I'm just going to build on these last few concepts. So basically, we've been told that now space is being revolutionized by volume of data. So we have more and more spacecraft, more and more data collected, but unfortunately we have a tight bottleneck, which is represented, of course, with what we can transmit actually back to Earth, because there is a very limited number of deep space capable antennas on Earth. And of course, we cannot just keep building another antenna. So similar to what happened recently in Earth with the internet, we need a more reliable and distributed infrastructure. And one way that we can do that is, of course, build some relay systems. For example, for spacecraft to rely more and more, or sorry, I'm switching to the mic.
I think you're good. Should be good.
Okay, so switching more and more to a distributed system and inter-satellite network between the spacecraft, so that we can optimize the process, and maybe the spacecraft can talk to each other, relay the data, and then only one single spacecraft maybe can transmit back to Earth with a high throughput. But of course, this is not enough. So we have to make a bigger infrastructure, but also to work on the data processing. And so AI again can come to the rescue, and we can try and train our algorithms to select only the data which is really helpful. But this also opens some big issues, because how do we know which information is actually relevant? And especially with regard to science, this is of course an open question to the audience as well. How can we understand what we don't know? Because if we have an exploration mission, we don't know what you're going to encounter when we are there. And so training the AI to discard some data, for example, because it's not really, let's say, replicating what we expected to see on Earth, can be, of course, a big challenge. So this is something that we have to address on.
Thank you very much. So again, reinforcing the input of the issue of volume. It almost seems like we're going into another area of data informatics or data processing. Historically, the volume of data was just pushing how much information can go through a pipeline. Now it's almost a new dimension in terms of the integrity of the information that has to be qualified as part of the communications channel. So thank you very, very much for that. Next, Melissa Mancini, grateful for your thoughts.
So, I mean, it's pretty clear that we're in the midst of the digital revolution in space. And as has been mentioned a few times today, the digital technology that's available on the ground for the longest time couldn't be used in space due to the harsh environments of space. And now we've developed that to the point where it can withstand the radiation effects of space, the temperature effects, and perform reliably. So now our satellites have these digital payloads that allow the mission to be more flexible while it's already in space. Whereas before it was a fixed mission, once it's in space, you can't really adapt it. Now we can adapt it, we can reconfigure the satellite while it's in space to provide energy at different areas on Earth as needed by the user. Also, the data processing is also done in space, and that allows for fast real-time responses, which is very beneficial for time-critical situations. Our Chorus satellite will use radar imaging to help in maritime surveillance, in land intelligence, and disaster response, and provide real-time alerts and support in those situations. So these constellations of satellites with digital payloads are very useful for things like global networking, to provide coverage to areas, remote areas, to connect those remote areas to areas that are well-serviced, for Internet of Things, and for edge computing. So very useful for all these things that are in very high demand today.
Super, thank you very much. And certainly some benefits are particularly applicable in the context of Canada, large geographic landmass, and we're looking to develop our not only our economy, but and the integrity of our society and its security. Important considerations. Giovanni, looking for the mic.
Yes.
That's it.
Yes. So, second question, very quickly. The answer, I'm reading it. Are we shifting digital economy needs to space?
Not the answer, by the way.
No, just the question. So I would like to stick again on cybersecurity, and my answer would be, in my opinion, not as much as we should, in the sense that concerning space, we typically tend to rely on a concept that is really bound to when the space race era started, where we had somehow space that was secure by definition, because access to space, being it physical or even digital, so in terms of communication, was possible only for large public institutions or very specific companies that were working as contractor. And with the shift of the digital economy, of the new space economy, where, as was also mentioned by Riccardo, for instance, where we see a value proposition also in the offering of ground station as a service. I mean, we know that, for instance, AWS, Amazon is providing ground station as a service that are really interconnected to internet. I mean, the access to space is really opened up to pretty much everyone and connected to internet. The paradigm should shift in a much stronger way from secure by definition to secure by design. So we need to inject the security of the system since the very beginning of the design of a system, of a mission, and since the very early stages, early at conceptual stages, so as to be able to ensure that the whole, let's say, data value chain is secure, and this should also encompass suppliers and subcontractors, etc., etc. And this, as I said in the answer to the first question, I would say is an enabler for a real space economy taking for future missions. Thank you.
No, thank you very much, and important that you've reinforced the issue of security by design, security being a fundamental quality that we would want in a system. So that's excellent. Next, back to you, Rob.
Yeah, so I mean, I think a strategic domain like space, you know, it's like a moment in time where, you know, the great nations of the last millennium sort of went to sea, you know, first with their navies, then with their mercantile fleets, and, you know, it really does feed the current, you know, the way the world is. So now we're into space. We're deploying our, you know, both our national defenses plus our our economy is up in there, and I think it's just by default that it's digitally enabled, and then it's by default that government, we see right now, designating key sectors, critical infrastructure, other key sectors. As a result, we see governments taking action on companies. Things like, for example, the SEC requiring officers of corporations to take personal liability and responsibility for their cybersecurity. You cannot outsource your risk. We see now government is taking that more seriously. Case in point is the SolarWinds Computer Act, where the SEC has now taken the CISO, the Chief Information Security Officer of this company, to court, allegedly knowing he had a poor cybersecurity program. He was told by his employees, and that, in their view, was potentially defrauding investors. So you can see that as an example of pushing, you know, digital responsibility. And so I think in this key sector, it's going to be a no-brainer. There will be, you know, there will be requirements. So we don't go to space just by prototypes alone. We go to space with programs. Right? So build a strong program around your space activities. You know, you'll set the direction for centuries.
Thank you very much there, Rob, and you certainly highlighted an important point. We see there our U.S. friends imposing legal responsibility for the security of systems on corporate and government leadership, and assuming that that same protocol will extend out to other critical systems that are based on space environment. Challenging there. How do we wrap our minds around that? But thank you. Next, Signor Proietti.
Okay, yes, I agree. We are moving things up to space. Digital is moving up to space. I would drop the term revolution. I think it's simply something that is occurring because of the time. Revolution is more like the French Revolution, or the Industrial Revolution, the October Revolution. But this is happening because we have a big cake in front of us, a new cake, well-baked, it's big, it's called space. People want to get to it, and we can because, as was said this morning, we have technology that we did not have 20 years ago. In particular, computers, so fast computers, this can run. Not only that, of course, we need to have sensors if we want to use these computers. For data analysis, we need to have materials, we need many things. And all of these are coming up, so we are all there ready to go there. And it's natural, the companies and the government, for different reasons, want to go to space. For companies, business. Business is economy, make profit, and it's perfectly clear. And I like it, but I would like to say we should be careful, because let's imagine we transfer everything, all our communication into space, everything up there, everything is running fine, great, super great, then the breeds start hitting, something starts happening, and like this, we lose everything. So my recommendation is only about plan B. I come from research, so I like having plan B, always there set. And I would strongly suggest not to drop everything we have on Earth, because it's better, it's more economical, convenient, more profit to go into space.
Okay, super. Thank you very much for that, Remo. And I think, Elena, I think you're going to bring us home here on this, please.
So I think that we all agree that the answer is yes. What I see is that there are both common aspects, but there's also a big different paradigm. So regarding the common aspects, what I can say is that together the digital economy in all what we said, so cybersecurity and flexibility, computations and so on, will allow satellites to provide new opportunities and new services and so on in all the satellites applications. And the space economy, for sure, is now and will continue to be ensured by the digital economy. And this is this has to be because we need to manage all the logistics in space and the 15,000 satellites constellations, and we need to manage these reconfigurable satellites in space and so on. So it's really a fact, okay? And also the digital economy is needs to be in space because we need to transform a ground-based society in a space-based society. And this includes the needs of the digital economy once. The big difference that I see is that differently from the digital economy, the space economy is largely capital intensive. And for this, I think that investors shall take this into account. They see numbers, and they need to understand that there's an hardware for space activities, that the environment is difficult, and so the capital that shall be taken and shall be put is a lot.
Well, thank you very, very much, and certainly putting some financial perspective on this. So grateful for those comments. Thank you. So I think we're very close to the end. What I'd like to do, though, very first, I would like to offer Signor Mazzini, if you have any quick comment that you would like to offer in light of what you've heard this afternoon.
Yes, thank you, but very, very, very shortly. I've seen my colleagues have spoken of many, many technologies: cyber, processing, edge computing, manufacturing, automatic manufacturing, AI, robotics. I don't know if I forget something. These are all technologies that are specific for classic business and are going to be applied to space. So the answer is quite simple to your basic question. There is, however, a technology that we have not developed on the Earth, and we need to develop specifically for space. And this is because space is peculiar. And this technology is worldwide cooperation. Because, you know, the orbits are circular and goes everywhere. There is no border to defend. And if we do not learn how to work together, we can mess up the moon, we can mess up the LEO orbits, and we can create a big mess in our space without producing additional value. So the old rules do not exist anymore. We had rules 10 years ago. These rules do not exist. There are no new rules. We have to establish new rules for cooperation. This is my last message. It's a technology to be capable to work together, and that's it.
Super. Well, thank you ever so much. And I know I'm pressing it here. I'd just like to offer if there's anybody, a very quick question, if anybody has. Sir. Okay, excellent question. Or do we have somebody who would like to take that question on? Yeah, I think Rem, please.
Okay, I give you our experience, because we are very close to companies. In human health, and we have a project about the study of the decrease of the sizing of people in space. We have projects about making antifungal surfaces. We have projects about making a photonic circuit for space, even though they don't exist on Earth. We have projects working on material that can make food last longer, and that can be used not just in space, but in other. So I have to say that it's like thinking of a long trip on sea, maybe, and you have nobody coming, you have not first aid coming, or a DHL coming if you have to, or Amazon coming to if you order something, and you have to be autonomous. So anything, and safe, because you don't want anybody cutting himself or injuring himself. So anything falling in this, which I would say most of the things, even the clothes, are good for that. When Marco Di Clemente mentioned 200 companies in Italy working in space, is correct. But there are 300 more that are not defined space companies, which are working, and the solution are for space, even though they are not space companies, because it happens that they fall there in that field as well. So it's really super broad. That is why it was so easy for us, even though, again, we don't know anything about space. At least I don't.
Please do.
I can augment Salvatore, perhaps on the additional tertiary businesses, right? So non-traditional space business that can benefit from space applications. I think we're going full circle back to, in the past it was more space materials were developed or things were developed for space that ended up being used, like thermal blankets and other. There's a million good examples. That's why we invest in space, because there's a lot of return. And I think now we're pivoting where a lot of, I'm going to call them digital savvy companies that are applying, whether it's on the cybersecurity side or the AI side, are applying knowledge that was gained in other industries into space applications, whether it's a rover on the moon or other places. So I think we all benefit from those tertiary, letting, let's call it non-traditional space business come into the space business and collaborate. Back to your point of collaboration, I think and communities in general, I think we need to even embrace a little bit outside of the space sector in some cases to enlarge the talent pool that we've cultivated in other industries that can now contribute to accelerate our space ventures together and build a new digital community for space. Yeah.
Thank you very much.
May I
Please.
add something? Yes, something possibly not directly answering to your question, but I think it can present some other angles on the topic you mentioned. So, so if we forget for a second the let's say tertiary sector willing to contribute to space for the sake of space itself, I think it's also very interesting to see the potential that space has for general companies' business. And would like to present you this example that I think, I mean, for me it was really fascinating because it gave me the opportunity to see things in a some slightly different way, if you will. So I attended a presentation where there was a company working in pharmacologic, let's say, biology field, and they actually leveraged a lot in producing basic molecula in space in the International Space Station, because at a certain point that they realized that on Earth they had the best processes ever in realizing this molecula, but they were not able to take off the gravity. And so bringing the process in space allowed them to, let's say, have a more, let's say, molecula that were even more perfect with respect to stability of links, etc., etc. So a way of thinking, let's say, the opportunities that space could offer also to non-space companies is to think maybe more generally on those sectors that are somehow affected by by gravity per se. And this could be in the material generation or let's say this kind of definition. So that could be also an interesting topic to be further explored potentially.
Please.
So for me, saying can a company not based in space work in space is like saying, can I never work in Antarctica and now I would like to work in Antarctica. Yes, it's actually the same thing. The space is a market. Now in Antarctica there's no one, but there's still people, some companies that develop specialized equipment to go to Antarctica with government funding. And now space is opening up, so it's all a matter of volume. Now the volume is there, so the market is there. You don't have to have, you just have to move in that direction. And this applies to every company, I think. And with the volume, as space booms, I think we'll see companies that will apply technologies to space business as they would apply to going to Asia or to Australia or to any other market.
Thank you very much. I think your question really prompted, I was going to ask the panel for one last burst on that, but I think it really prompted a very good discussion, sir. Thank you very much for that question. All right. So I think unless there's anything further, I think we've basically pushed our time limit. People's fund meters are pegged, I think. So with that, I think this panel has done an excellent job. We've given them two tough questions. They've been able to provide some very synthetic, precise, coherent response. It's going to be a bit of a chore to try to put this together into something coherent in the next 5 minutes. But I would like you to please join me in offering them a rousing round of applause for a great work. Thank you very much. Thank you very much.
If I may also, I would like to offer an applause to Roberto and Anil that organized this panel very professionally. Thank you very much.